Any questions so far? Notice how it's right in the middle of all the points. And it's a straight line. It does not curve. Since we are talking about straight lines again, we're going to go back and we're going to review how to write an equation for those lines. Okay, and what form did we always write those equations in? Okay, y equals mx plus b, where m is the slope and b is y-intercept. So starting with the black line, what is our slope and y-intercept? Which one is the easiest to see? The y-intercept. Okay, because it hits the y-axis at 3. And then we find our slope. What's the definition of slope? Rise over run. So I find 2 points. Rise 2, run 2. 2 over 2 simplifies to 1. So our equation. Y, 1x plus 3. Okay, very good. For the red line, again, write down what your slope and y-intercept are. Y-intercept is easiest to see. It's the y-axis at -1. Slope, rise 2, run 1. So 2 over 1 is 2, which makes our equation 2x minus 1. And then the last one's a little bit more difficult. Not as easy usually for students. Okay, what's the y-intercept?
1.
Okay, that's still not too bad. And then the slope. Okay, how do you get -1? Very good. We're going down 1, which gives us -1, and then we run 4. Very good. So our equation becomes x plus 1. Don't forget your x in there. Questions on slope-intercept form? Okay, that should have been review. Then we talk about trend line and line of best fit again. But we are going to practice this now a little bit here. It says make a scatter plot of the data in the table. So if you look at the table, we have weight of a panda. I give you the age in months, the weight in pounds. You have to determine what's independent, what's dependent.
Age of month.
Age is dependent on weight.
Yeah.
No, the weight is dependent on age.
The weight of the panda is going to depend on its age. The older it is, the more it's going to weigh. Okay? So, if weight is dependent, what variable is that?
Y.
That's y. Dependent is the y. So weight is y, age x. And that's what I put on my graph. See, look. I put the age down on the x-axis, the weight on the y-axis. Then it says draw a trend line after you make your scatter plot. So I made the scatter plot. The trend line is also drawn in for you. I did that because then it makes us go a little bit faster and we can practice the more difficult part, which is writing the equation, number 3. So you have to write the equation for the trend line. And there's a couple things that you have to make sure that you do. You only write the equation for the trend line, not for the scatter plot. Okay, and I say that because when you pick points, you're going to have to pick points to find your slope. Okay, what's your y-intercept? You don't know. And you're not going to know until you find your slope and use your slope to help you find the y-intercept. So now when you find your slope, what we did on the last page is we did rise over run. But you need to find 2 points. And when you find 2 points, you find them from the line. You do not use any of your scatter plot points. You use points from the line that you drew. Okay, so I'm going to find, when I pick points, am I going to pick a point like this? Why?
It's not accurate.
You don't really know what that is, right? So when you pick points that hit grid lines. Let's pay attention, please. Not all of us are paying attention. Okay, Brooklyn? Yes, where the grid lines meet. And it has to touch the blue line here as well. Okay, Lucas, you find one? Okay, 7 and 30. Careful, that's a little bit above. How about 8 and 36? See how 8 and 36 hits the grid lines? Okay, how about another one? Now, this one is more towards the end of our line. Try to find one more towards the beginning of your line. You want to find one at the beginning and one at the end if you can. Justice? Okay, that's a little bit above 24. Let's go more a little bit back. Jonah? 3 and 12. That's a better one. I think that one's pretty close to that line there. Okay, so now we have the points. And whenever I find my points, I write them down. So I have 3, 12, and then what was our second one? 8 and 36. The reason I'm going to write them down is because now I can find my slope. What's the definition of slope other than rise over run? Change in y over change in x. So what's, yes it is. What's the change in our y's from 12 to 36? 24. Okay. And then what's the change in our x from 3 to 8? 5. Okay, so now we have 24 over 5. And what is 24 divided by 5? Mental math. 4.8. 4.8. Okay? Because it's like 4/5. It's 20, and then it's 4/5. So you have the 4 out of the 20, and 4/5 is 0.8. So 4.8. And then now we found our slope. We're going to use that to help us find the y-intercept because we can't see the y-intercept. And you're going to have problems where you can't see the y-intercept because does it have to necessarily go through 0?
No.
Does it have to go above 0?
No.
It doesn't. So now you're going to have problems that do this, and you're going to have to use your slope to help you. How can I use my slope to help me find when it would hit the y-axis? Okay, you can make it negative and drop, but where are you going to go to other than the graph? Where should you go?
To the table.
Yes.
To see where it hits 0.
When you want 0. Very good. Remember how I said the y-intercept is also when x is 0? So we're going to use our slope. I go back 1. That means I have to go back how much here? What was our slope? 4.8.
Yeah.
We're going to go back 4.8. So we subtract 4.8 from 2.5, and we get about what then? Negative 2.3. Now, let's think about this. We're talking about the weight of a panda. And at 0 months old. At 0 months old, what does that mean?
It's not born yet.
That's when it is born. As soon as it's born. Okay? It doesn't make sense to be negative 2.3 pounds. It doesn't. And that's okay. In problems like this, when you're writing your equation, your numbers are theoretical. They're not actual. Okay? So theoretically, if it followed the pattern at which this panda is growing, it would have had to been negative 2.3 pounds when it was born. Obviously, when it's born, it's not going to be negative 2.3 pounds because it probably grew quicker in its first month than it did later. I don't know. So now we have our slope and our y-intercept. What's our equation? in this problem, what did we say X represents? The age. And what does the Y represent? The weight. Okay. Why would I want to make that equation?
So you can know when you can see when
Okay, say you are taking care of this panda, whether it's in the wild or at the zoo, okay? And why would you want this equation if you're taking care of this panda?
how big he will grow.
But then you know approximately how much it's supposed to grow every
Day or something.
So approximately how much is it supposed to grow every month? 4.8 pounds per month is what we should expect. Okay? Why else might I use this?
To know if his health is good or bad.
Okay? This equation, think of it outside of this classroom like in the business world too. This equation is going to allow me to predict how much my panda is going to weigh maybe at 24 months old. So 2 years old. Maybe at 30 months old. Okay? Because what am I going to do with 24 months or 30 months?
Build a house.
I have to put that number into my equation, and then I'm going to see how much the panda is going to weigh. So I know it says approximate the weight of a 7-month-old panda. 7 months is what? Is what? 7 months. Age or weight?
No, age.
Age. Age is represented by which variable?
Why?
X. So I'm going to substitute the age I was given in for X and solve. I'll know my weight. So I substitute 4.8 times, now instead of X, 7 minus 2.3. So we take 4.8 times 7, we get 30, I think it's 33.6. Maybe it's 32.6.
I think it's 33. It's 33.
Okay, minus 2.3.
31.3.
So it's about 31.3 pounds. Now, I can always double check this. Go to my graph. At 7 months, go up. Is that at about 31.3 pounds? Then we're probably pretty close. So we did things right. Now, let's do what I asked you earlier. At 36 months, 3 years old, how much can we expect our panda to weigh? So what are we going to do now? That's correct. 36 months instead of 7 months. So 4.8 times 36. So the panda's 3 years old.
Wow.
What's 4.8 times 36?
We need X here.
Get a calculator. Okay, minus 2.3. So now you're at 170.5 pounds after 3 years old. Okay. So see why we might want to use an equation. Why we go through the trouble to get the equation. Okay, we're going to try one more then. Now we're talking about our same panda, but instead of weight, we're talking about the length in inches. So how tall he is. Okay. I made the scatter plot for you. You draw your trend line in. When you draw a trend line, the trend line has to be a straight line, so you need to get a straight edge for your trend line. Okay?
Straight edge.
Why did you erase 12? So where are you going to go now?
My mom's picking me up at 11:30.
Okay. Make sure you're drawing your trend line, please. This is not time to visit. You're drawing your trend line where you think it best fits all of that data. Does it have to go through 0?
No.
Okay, it does not. No. It's not going to start at 0. Now, notice my trend line. It is one line, and it is a straight line. Okay, it should never curve. It should not go from point to point. Okay, it's just one line that you think best represents all of those points. You're going to have some points above, some points below, some right on it almost. Yours may look a little bit different. Is everybody's trend line going to look the same? Probably not. Yours might start a little bit lower. It might start a little bit higher than mine. Okay. Now what we're going to do is write an equation for the trend line. So you find the slope and your y-intercept. Is this y-intercept a little bit easier to find? Yes, it is. I can see where it hits this time. I don't have to use my slope to help. Okay, yours might be a little bit above or a little bit below mine, but my y-intercept is nice and easy. It's 5. How about my slope? What do I have to do with my slope again? And grid points. Okay, so are there any points that hit at nice grid point lines?
Yeah, one.
What?
15, kind of.
3 and 15. 7 and 25 is close. 9 and 30 is close. I'm going to use 9 and 30 because it's more towards the end. And then which one should I use that I know?
2 and
My y-intercept, right? 0 and 5. One at the beginning, one at the end if you can, of your line. So now I have 0, 5, and I have 9 and 30. Change in y. Change in y. 25. Change in x. Okay. So 25 divided by 9. What is it? 2.9. 2.7. So we're going to round it to 2.8. Okay. What is our equation then?
5x.
No. Slope first. X plus 5. Okay, now, again, I want to know how much a 7-month-old panda would be in length. Why am I putting 7 in for X? Why not for Y? Age is on the x-axis, so I take my age and I substitute it for X. So we're going to do 2.8 times 7 plus 5. Plus, sure. Total? Okay. 24.6 inches. Now, if I go to 7 months, is it close to 24.6?
Yeah, pretty dang.
It's really close to 24.6, isn't it? Okay. Now we want to know a 10-month-old panda.
Do the same thing.
33. 2.8 times 10 is 28. 28 plus 5 is 33. Now, is 10, here's 10, because here's 9, so 10 is here. Is that close to 33?
Yep.
Yes, it is.
Yes.
So we did things correctly. Before you close it up, one last thing. What if I ask you, how old would a 30-inch panda be? 34. What did I just give you? I gave you 30 inches. What is that? That would be the length, right? The length. What is the length? So I'm going to put 30 in for y, and I'm going to solve for x. How would I solve for x? Yes. 30 would go here. I would subtract 5 on each side, then divide by 2.8, and I'd get how old our panda would be at 30 inches long. Okay? So depending on the information I give you, depends on which variable you substitute it for, y or x. Okay? So your homework tonight is to work on I-6.